Let us consider the first physical quantity of motion, distance. Distance means the actual path traveled by an object. Look at the figure that is given in the slide. Let us say the object is moving or is traveling from path O to A to B, B to C. Okay, so in this case, the object is traveling a path, and that is why I say that the distance covered will be OA plus AB plus BC plus OC if the object returns to O point. So if I total up all these kilometers, I would get that the object has traveled a path of 120 kilometers. So the object has covered a distance of 120 kilometers. Distance is a scalar quantity. 120 kilometers could be to the north distance, south, east, west. It would still remain as 120 kilometers. So it's a scalar quantity. It does not need direction to specify distance. Then it is always positive. Okay, even if you move behind O, still the distance covered would be positive distance. It cannot be zero. Why it cannot be zero? If I say that the distance is zero, means the object has not moved. So where is a question of motion coming into picture? So it cannot be zero. And since it is the length, it is always measured in meters. In the previous slide, we were talking about distance. Distance means the actual path traveled by an object. Distance is a scalar quantity. Now this slide will tell us about displacement. There is a difference between distance and displacement. Let us try to see what it is. Now displacement means it is the shortest distance or path between the initial and final position of an object. All of you look at the scale that is given on the slide. I am referring to the same scale which we have used in the previous slide while studying distance. Let us say a person moves from position A if you remember the reference point is O again in this case. So let us say that the person is moving from O to A, then to B, then to C, and then finally the person comes back again to O. Then how much has that person traveled? If I sit and calculate the path which we have done in the earlier slide, that would be calculating distance. But now I want to find out by how much has that person displaced. So his initial position was O. His starting position, as in starting position was O. His final position is also O. So is there any displacement that has occurred? No, zero displacement. Let us consider the same object once again. Now, say the object is moving from position O, so starting point is again O, to A, then to B, and then to C, and he stops. Okay. Now, if I say that the person has initial position was O, and the final point where the person stopped or that object stopped is C, how much has that object displaced? If you look at the number line and see, you will see that the object has displaced by 25 kilometers. That is the difference between initial position and final position. Let us consider one more example. Okay, please note this displacement was in the from in a 0 O to C is positive plus 25 kilometers. Let us see one more scenario. Suppose the object starts moving in the opposite direction right from this reference point or right from the origin point. Right now I am facing the screen. All the distance that we have, displacement that we have talked about so far was towards right. Let us say that when I am facing the screen, the object now starts moving towards my left. Now the object is moving completely in the opposite direction of that number line. So whenever that object goes and stops, that part, or if I measure that part, I will say that the object has displaced, and that displacement is negative. If you remember the number line, opposite direction, it goes negative. So let's compare once again. Distance, always positive, cannot be zero, because if I say the distance is zero means the object has not moved at all. So there is no question of motion coming into picture there. So distance, always positive. Displacement, it can be positive, it can be negative, and it can be zero also. Now all these possibilities are there because displacement can be determined by two parameters. One is its magnitude, the numerical value, and two is its direction. So if an physical quantity has been determined or needs two major things like magnitude and direction to justify it, then we would say that it is a vector quantity. Okay, so an object is displaced. Only telling you that the object is displaced will not satisfy, or will not be able to measure it, because I need to know in which direction, north, south, to, fro, up, down, whatever it is, I need to know the direction. So I need to know the magnitude, I need to know the direction. Thus displacement is a vector quantity. Again, since displacement is related to the length, its SI unit would be in meters. Okay, now I want you to think. All of you have a vehicle at home, let it be a two-wheeler or a four-wheeler. It's got a dashboard. Okay, dashboard means you see amount of fuel, and then maybe a temperature in the car, or maybe something that measures speed over there. Okay, so all these indicators, a place where you get to see all these indicators is called as a dashboard. So go and check the dashboard in your vehicle. Okay, there'll be some numbers. As the vehicle moves, there'll be some numbers that keep on moving. Those numbers are calculating something. Okay, tell me what that meter reading is calculating. You generally that is called as an odometer, and you generally set it to zero when you want to measure something. Okay, so what is that something are you measuring? Are you measuring the distance, or are you measuring the displacement? Tell me. This slide will help you differentiate between distance and displacement. Both of them are physical quantities that help to define motion, or help to define the change of position of an object, and also locate the position of the object. Look into the picture that is on the right hand side of the slide. A person is moving from one point to the other point. The distance is denoted in blue dotted line. Okay, so that path is crooked, curvy, whatever is the path that is there, it would be distance covered. Whereas the green dotted line that joins the initial and the final position, and it is the shortest distance between initial and final position, that would be displacement. In the differentiating column, thus we say distance is the length of the actual path covered by an object irrespective of its direction, whereas displacement is the shortest distance between initial and final position in a particular direction. This means distance needs only magnitude, and thus it is a scalar quantity. Displacement would need magnitude as well as direction, thus making it a vector quantity. Distance can never be negative, okay, and it has to be positive, and ideally it cannot be zero also. If I say that the distance is zero, which means the object has not moved at all, then where is the question of object being into motion come into picture? No. Displacement, it can be positive, okay, it can be negative, or it can be zero. We have studied what is positive, negative, and zero displacement in the previous slide. Fourth point, distance between 2 points may be same or different for different path. Take the same example. If I am traveling along that blue dotted line, which is on the right hand, or which is above the green dotted line, that's a different path that is taken. So accordingly the distance will change. But from A to B again, I will take another route which will have a different path. Again, the distance will change. So I have two different paths where the distances are different, or it can be same also. If they are identically on the other side like a mirror image, it would be same also. But they are different path and different directions, distances also. Whereas displacement, it will always be same, because displacement means the shortest distance between initial and final, and that would be only one. Okay, so displacement between 2 points is always the same. Distance between 2 points can be same or can be different for different path. Okay, think, I've got a question for you. All of us use Google Map Assistant to move from one destination to other. At times when you put in the destination, it calculates and tells you, okay, the shortest route on your way is this, and then we follow. So what do you think the Google Map Assistant is doing? Is it calculating distance or is it calculating displacement, since it is talking about shortest route and all? So think and tell me whether it is distance or whether it is displacement. Let's now look at a numerical which is based on the concept of distance and displacement. A farmer moves along the boundary of a square field of side 10 meters in 40 seconds. Okay, so which means he is moving along a square boundary where every side is 10 meters and time taken to complete that side is 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? Now, before you actually read the other details on the slide, have a look at the figure. A, B, C, D is a square farm where every side AB is 10 meters. Being square, all the sides would be 10 meters. So, in the total time that he took to cover this area, this perimeter was 2 minutes 20 seconds. Let's convert it into seconds. That will be 140 seconds, which means he was moving along the boundary of that square field for 140 seconds. If every side he takes 40 seconds, in 140 seconds he will cover 3.5 rounds. So if you start from A and cover 3.5, he would reach point C. Now we have to find out magnitude of displacement. If you remember, displacement would be distance AC. It is the shortest route from the starting point. He was at A, now he is at C. So if I join A and C, being square, triangle ABC would be a right angle triangle. And now I can find out distance AC using the Pythagoras theorem. If you remember, AC square is equal to AB square plus BC square. Since ABC is a right angle triangle, I can apply this theorem. So if you plug in these values over here, you'll get AC is equal to under root of AB square plus AC square, which is under root 10 square plus 10 square, and I'll get it 10 root 2. Plugging in the value of root 2, which is 1.414, you can calculate it or you can use other ways to find out that value. I will get the answer AC is equal to 14.14 meters. So the magnitude of displacement which the farmer had at the end of 2 minutes 20 seconds is 14.14 meters.